So today it's the 29th of June 2016, and this tape is about a test that I did yesterday, and I just wanted to tape it to explain what I did. So basically it's all about 4 axes inside of a 3D room, a 3D space. So we see here that all axes have an angle of 120 degrees to one another. So that's a model that seemed very interesting to me. So what I did, I asked a good friend of mine to support me with data, and so we took the data of a hypersphere. So we took a 4D sphere and calculated from the circular coordinates into Cartesian coordinates. So what you see on the left-hand side here are 4 parameters for each axis. And what I did in this table is that I converted each data set to these 4 axes inside of the 3D room. So this first data is being calculated inside the yellow spaces here, and the result of the 3D coordinate is right here. So what you see, it's over 7. So, and what I did then, that I integrated these 7,000 data sets into another software that shows 3-dimensionally what the cloud is about. So, and what we see here is the result. And I find that it's very, very interesting. So if we take the data of a 4D sphere, of an hypersphere, and translate it into a 3D room, then we have exactly a normal sphere as we would expect it from a 3D room. So difference that we have is that the coordinates lead to a filled sphere. So if we convert 4D data of a sphere into a 3D world, like the 4 axes that I showed you before, we have a filled sphere in 3D. So, and I think, to me, it is a really outstanding result, because it's not only a filled sphere, but also we see that we have like 2 poles inside of it. So if I rotate it, and you see quite well that these points lead to another spheres inside of that. So to me, that looks like with lines between. So it's very similar to a magnetic field. So and my thought was that this is maybe an interesting result when it comes to magnetic field theory of Einstein. So if we talk about the thought that higher dimension could represent like electromagnetism or other habits, so it could be a good first thought that the 4th dimension is something like a magnetic field, because somehow we have 2 poles right here, and if we zoom into all that, we see that, I hope I get it done right now, yes, if I go inside of this space, looks a little bit like stars, then we see, and I try to rotate it, that we have inside of some kind of field lines. So if you go over these points, you see that they may represent kind of field lines. So, and it also seems that we have a fractal, because this sphere that we see inside of it also have two poles right here. Here's the first pole, here's the second pole. So our experiment leads to really interesting data. And so because my first thought is that this fourth dimensional data inside of a 3D room look a little bit like magnetic field lines, so maybe this is a way or another result that may lead to the description of a magnetic field inside of a multi-dimensional room. So that's why I taped this, and I will show it again, like zooming in, that you get an impression of it. So right here you see quite well the other spheres inside of that. So, and even, yes, other structures. So it's a very interesting structure. I hope it's not only an artifact, like converting all this and only having an artifact. So to me, it really looks like kind of field lines between two poles. And maybe that's the first way to describe the fourth dimension, maybe as the data set of magnetic field lines, and that is not the sixth dimension, maybe it's the fourth dimension that covers magnetic field lines. So yes, that's it for the moment. My name is Bodo Zeidler, so I'm not a physicist. I'm somebody who's working on some things and having fun with that. So I hope you enjoyed it, and yes, thank you very much.